So this is PK's questions. So first off, this is the basic question in which there is nothing new. In this question there is nothing new. The question can be easily solved like this. This 1437.6 Newton. And unbalanced force remained is can be easily solved like no need to solve like this. You can go the big method. MRP R omega square 1 minus c whole square cos square theta plus c square sin square theta. You can go like this and you will get the answer as option C. ये देखो, ये क्वेश्चन जो है, द बैलेंसिंग ऑफ अ रिजिड रोटर कैन बी अचीव्ड बाय अप्रोप्रिएटली प्लेसिंग बैलेंसिंग मासेस इन. एक मास को अगर बैलेंस करना है तो सिंगल डायमेट्रिकली अपोजिट या फिर दो बैलेंसिंग प्लेन से भी कर सकते हैं हम लोग, बिल्कुल कर सकते हैं. जैसे वो वाला केस. सो द केस लाइक दिस. और this. So this is an ambiguous question. The third question is the ratio of maximum. This question is important. The ratio of maximum primary force to the maximum secondary force of a V 90 degree V twice twin engine having stroke length 12 and connecting rod length 20 is maximum primary to maximum secondary of a engine. ये होता V90 engine. Here also piston, here also piston. That's why he told twin engine. This is 90 degree. 90 degree, so alpha is equal to 45 degree. 90 by 2. Angle included divided by 2. Now he told the ratio of maximum primary to maximum secondary. You have to directly remember this. Maximum primary force in maximum unbalanced primary force. It actually wants to say maximum unbalanced primary force and maximum unbalanced secondary force. It's n by root 2, where n is ambiguity ratio, obliquity ratio, L by R. Length of connecting rod is 20 and R is 6. So you have to directly remember this. In a reciprocating horizontal engine, the inertia force due to reciprocating mass has the piston effort at. Actually, what is a piston effort? The direction of piston effort is it tries to move the piston in that direction. Okay. And what he is telling inertia force due to reciprocating mass. The inertia force due to reciprocating mass, it wants to say that unbalanced force. Inertia force was caused by, unbalance was, actually I don't know the thing, but here in the, by inertia due to reciprocating mass, it's want to locate us to the unbalanced force, which was this. Ignored secondary. This was this, and the original direction is like this. Original direction is like this. Piston effort original direction is this. Its direction is like this. I ignore the secondary. Now when theta is greater than 90, this unbalanced is towards this. So more than 90, it supports the piston efforts. So answer will be theta is equal to 120 degree. This is important question and can be asked. In locomotives, the secondary force is equal to, secondary force means secondary unbalanced force is equal to the centrifugal force produced by an equivalent crank running at twice the speed and having an equivalent radius. Okay, so what we actually do in that secondary thing is, we know from rotating mass the unbalanced force is like this, mr omega square cos theta. Now when we study secondary force, the secondary is like secondary unbalanced force, it's like, so we convert it like this: mrp r by 4n 2 omega square cos 2 theta. So this was revolving mass unbalanced force. This is secondary unbalanced force in reciprocating mass. How we can equate this? So this is like this: mr omega square cos theta. Okay, no worries. So the thing is, we can convert the secondary force like this, having equivalent crank radius r by 4n and twice the speed 2 omega. Okay, r by 4n can also, answer is r by 4n, no worries, but n can also be written as r by 4, n is l by r, so r square upon 4l, so r square upon 4l. The resultant unbalanced force is minimum in reciprocating engines when the part of the mass reciprocating is balanced with rotating mass. कितना परसेंट reciprocating mass को अगर balance करोगे, so then we get the minimum unbalanced force. Minimum unbalanced force की direction we know, it's ये direction और formula we know that mrp r omega square 1 minus under root 1 minus c square sin square theta plus c square cos square theta, c square cos square theta plus c square sin square theta. Yeah, this we know. What I was saying is, when we get the minimum value as this, we get the minimum value when we balance 50% of the reciprocating mass and 50% of the reciprocating mass. How this comes as, yeah, this c is equal to 0.5 has two importance. First, at c is equal to 0.5, the unbalanced force becomes independent of theta, and at c is equal to 0.5, the unbalanced force is minimum. This direction unbalanced force, yes, it turns out to be horizontal vertical. This is minimum for c is equal to 0.5. Yeah, pk have derived it by putting values. You put the values of, you take c square as theta as constant, and you put the values of c square, c, different values of c. The curve goes like this: unbalanced force c, minimum at 0.5. So this is the 7th question, which we have done many times, so you can easily do it. What should be the angle between the cylinder axis if the primary force of two cylinder V engine are to be completely balanced? Okay, what should be the angle between the cylinders axis? Means what should be this? If primary forces of two cylinder V engine, this is two cylinder V engine जिसके लिए पीके ने सारे फार्मूला डिराइव किए हैं. An angle if between this axis is 90 degree, then the component of primary unbalanced force is 0. How we get this is none of our concern, but we can do it. And directly remember this, as I told, just primary unbalanced force is completely balanced if theta is equal to, angle included between is 90 degree, and if angle included is 120 degree, then secondary unbalanced force becomes 0. If involved angle is 90, primary becomes 0. If 120, secondary becomes 0. At 120, I cannot say if primary becomes 0 or not. So these are direct questions which I have to just do. I have told the concept of, I will again tell the concept of, okay, these are some points. So primary, okay, this is useless. This all are useless. Just the important thing is this. I told in the previous videos, one of the videos, this actually, in that video, I want to apologize. It was a really imaginary crank only. Secondary imaginary crank. Here it is a reverse crank. Reverse crank. That there was imaginary secondary crank only. So there are four cranks: primary direct crank, or primary crank, or original crank. Okay, so again telling: primary direct, primary original, or original crank. All the names are same. Second is secondary imaginary. Secondary imaginary, because secondary does not really exist, we imagine it. Secondary imaginary, whose r by 4n, if its primary direct goes theta clockwise, this goes 2 theta clockwise. Then the third is primary reverse, and fourth is secondary imaginary reverse. Secondary imaginary reverse. This type of question is very important. Consider a reciprocating engine with crank radius r connecting L. Secondary unbalanced force. This case is equivalent to primary unbalanced force due to virtual crank of r by 4n. R by 4n can also be written as r square by 4l, rotating at 2 omega. Original was omega, rotating at 2 omega in the same direction. In reciprocating engine, primary forces. One question I told, that reciprocating engine we can 100% balance primary and 100% balance reciprocating engines forces. This concept is used in inline engine where we can 100% balance. Nice, as I told, if we take 6 cylinders, we can perfectly balance primary, secondary, primary couple, secondary couple. We can perfectly balance. But he is not asking this. He is asking about us. The basic case that we study is that piston. In this case, we can, but we do not. We can, of course, but we do not completely balance the primary, means unbalanced force, horizontal force. We only balance a fraction. Actually, in this case, of course, we always neglect the secondary. So primary force is partially balanced, like c is equal to 2 by third, 1 by third. Why? If we completely balance the primary force, which is occurring in horizontal direction, anyway we ignore the secondary, then all the primary which is in horizontal direction, if we are balancing in horizontal direction completely, then exact same magnitude appears in vertical direction, causing hammering effect. That's why we do not do it. That's why we leave some in horizontal and some side effect we get in vertical, and net goes like this. Yeah, assertion and reason both are correct. Just now I told why we don't completely balance horizontal, why we do partial balancing only. This is the 11th question, which when revising you have to do it. I don't think it is too hard, and if it's find you hard, lecture 16th of Theory of Machines 2 by PK. This primary direct, there are four I told: primary direct, secondary imaginary, or it is also called secondary direct, primary imaginary, primary reverse, secondary reverse. Theta clockwise, 2 theta clockwise will be the answer. 12th A. Yes, 12th A is the real answer. Now the 37th question. Yeah, 37th question, the answer is B. Primary balance, if I told you the statement, if dynamically balanced, then static balance is automatic. This is 13th question and the answer is A. 14th question, the answer is B. 15th question, the answer is B because hammer is maximum vertical unbalanced. 16th is B. 17th answer is A. The figure is actually like this. This is not a mass, this is just a connection. The 18th is A. Along the traction force is along a line of stroke, and yes, we ignore the secondary any day. It is unbalanced portion of primary force, yes, because we have always neglected the secondary forces in any type of engine, in any type of locomotive, anything we do. So it's the thing we study is when we do like this original this direction, then we do this direction, it's only we take primary, this direction only effect of some primary lefts, some vertical left. Okay, and the 19th is B. 20th is, you have to do it. 20 is answer is you have to just see it. Answer is not written, so yeah, the answer is done like this. 21 answer is C. 22 answer is direct crank and R square secondary reverse. Direct crank 30 clockwise, so secondary direct is 60 clockwise, so secondary reverse is 60 anti-clockwise. B. 23 question is, this is question of first of all inline engines, and I don't think I am going to study the inline engines. I am leaving this. This is not first of all, this is not the case of revolving masses that I study now. This, don't confuse it with this is not the case of that case. For third case, this is a new concept of inline engines where there are more than two engines and all at some angle. Don't worry, we don't have to do this. 24 answer is B. 25 the answer is N. If N increases, then in a primary unbalance, the formula is MRP R omega square cos theta. Is there any value of N? So the N does not affect the primary unbalanced force, but in secondary there is N and it is downwards. So if N increases, the secondary unbalanced force decreases. That's why we take more N. So we can easily neglect the secondary unbalanced force. 26 I did. 27 answer is C. Yes, it does lift due to it does not lift due to gyroscopic couple. Yeah, there's, if it is turning left or right, then it can turn lift, tire can lift up and down. But if it is just moving, okay, so I have to just explain it. If the car is just moving like this, then due to hammer blow, the wheel has a tendency to lift or compress. Sometimes it compresses the wheel, sometimes hammer blow tries to lift the wheel. In gyroscopic couple only comes in effect when, if it is moving horizontally, it does not come into effect, gyroscopic couple. But if it's tried to turn left or right, then it comes into effect, because the axis of rotation needs to be turned while rotating. So the answer is C. Locomotive wheel is due to hammer blow and not due to gyroscopic. Yes, if it is turning, then it is due to gyroscopic coupler. Jet the 28 is B option. Okay. So here we completes the PKS questions.